After collecting the data, I want to organize the data and I want to show the data. For that, I'm going to have the frequency distribution. It tells the proportion of the total number of observations associated with each category. A histogram is a graphical representation of data using rectangle bars of different heights. Hello to all, a warm welcome to my new session on third unit, and the chapter name here is Statistical Methods. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have discussed in my last session. In my last session, I started with how to perform numerical integration. Along with that, I have discussed Simpson's 1/3 rule as well as 3/8 rule and trapezoidal methods. But in my today's session, I'm going to discuss frequency distribution. So what is frequency distribution? Frequency in the sense what I'm going to use to identify the observation, how many times it is repeated, and to represent the repeated observation, I'm going to use frequency distribution. In the sense, if I consider the data like 1, 2, 3, 4, 5, 2, 6, 3. Now, 1 appeared one time, 2 appeared twice, 3 appeared twice, 4 one time, 5 one time and 6 one time. Okay, now to represent the occurrence, I'm going to use frequency distribution. Now dear student, a frequency distribution shows the frequency of repeated items in a graphical form or tabular form. So dear student, if I consider frequency distribution, okay, it is mainly used to represent the frequency in the sense repeated numbers in the form of graphs or in the form of table. So dear student, if I consider graph, I can have pie chart, bar chart, line chart, etc. It gives the visual display. Okay, in the sense, if I consider graph or table, by seeing the table or graph, I can able to identify the frequency as well as repetition of the numbers. It gives a visual display of the frequency of item or number of item they occurred. Now, frequency distribution is used to organize the collected data. So, dear student, if I consider marks, that is nothing but the final exam marks or internal marks. I have group of data or I have group of item. Now I want to organize all the marks in some manner. For that I am going to have the frequency distribution. So here frequency distribution is used to organize collected data in the form of tables or in the form of graphs. The data could be marks scored by student or temperature of different towns, points scored in any match. Even I can able to consider volleyball match or cricket match, etc. So after collecting the data, I want to organize the data and I want to show the data. For that, I'm going to have the frequency distribution. So here, once I collect the data, now I want to organize the data in some meaningful form. Okay, for that I'm going to use table or chart. So this is known as frequency distribution. So here, if I consider the student, see here, I have 10 students and these are the marks scored in the quiz. Okay, so here I have the numbers like 15, 17, 15, 20, 17, 17, 14, 14 and 20. Now I want to represent these data in some meaningful method. So I'm going to have the frequency distribution and I'm going to organize the data. So here if I see this table, I can very easily identify that 15 marks scored by 2 students and 3 students scored 17 marks and 20 marks scored by 3 members and 14 marks is also scored by 2 members. And when I add all this number of students, it is 10. Okay. Thus, frequency distribution in statistical helps us to organize the data in meaningful form. Okay, so organize the data in an easy way to understand its figures at a glance. In the sense, when I see this table, I can able to understand very easily that these are the quiz marks and these are the number of students who scored particular marks. Now, frequency distribution graphs. In the sense, if I consider frequency distribution, I can able to have graph. In the sense, whatever the data I collected, that can be represented in the form of tables as well as graphs. So here graph is nothing but the pictorial representation of data. There is another way to show the data, that is in the form of graphs, and it can be done by using frequency distribution graph. So here graph also helps us to understand the collected data in an easy way, and some of the example here is bar graph. So dear student, let me to consider the data. Okay, see, I have 3, 5 and 7. Okay, so this is my x-axis and y-axis. Now, if I'm going to represent the data in the form of bar, okay, then this is known as bar graph. See here, this is 3, 5 and 7. Okay, by seeing this one, I can very easily understand that, okay, which data is going to have higher value or highest value. So, bar graphs represents data using rectangle bars. So, here this is nothing but the rectangle bar. Okay, so here data are represented by using rectangle bar of uniform width. Okay, along with equal spacing. So here it is uniform width and equal spacing. So this is spacing. Okay, so this is nothing but the width, uniform width as well as equal spacing. Then I'm going to have histogram. A histogram is a graphical representation of data using rectangle bars of different height. So here histogram is nothing but, okay, once again it is example for graphical representation using rectangle bars with different height. In histogram, there is no space between rectangle bars. Okay, there is no spacing between rectangle bars in histogram. And if I consider pie chart, A pie chart is a type of graph that visually displays data in a circular chart. Okay. So to represent the data, I am going to use circle. Now, based on my frequency or data, I am going to divide this chart. Okay, this is known as pie chart. Okay, it looked like a circular. I'm going to divide the data. Now, frequency polygon. So, frequency polygon is drawn by joining the midpoint of the bars in a histogram. So, dear student, this is also one kind of graphical representation, and here we are going to draw the bar in a histogram by finding or by joining midpoints. So these are the certain type of graphs. Now dear student, I am going to have the different type of frequency distribution, that is group data, ungrouped data, as well as I am going to have relative frequency distribution as well as cumulative frequency distribution. Let's see all these types one by one. So what is ungrouped frequency distribution? It shows the frequency of an item in which separate data values. So as the name itself indicates that we are not going to have a group of data. Here we are going to have different, in the sense separate data values. And if I consider grouped frequency distribution, we are going to have the group of data and we are going to get some range. So in this type, the data is arranged and separated into groups. So here data are arranged into separate group and that is known as class interval. Okay, if I get 1 to 10, 20 to 30. So this kind of data falls under grouped frequency distribution. The frequency of data belongs to each class interval is noted in a frequency distribution table. The grouped frequency table shows how the distribution frequency in a class intervals, in the sense whatever the data I have, for that I am going to construct the table. Okay, and that table itself known as class intervals. Then I am going to have relative frequency distribution. It tells the proportion of the total number of observation associated with each category. So dear student, once again I am going to have group of data or I am going to have group of observation. It tells the proportion of the total number of observation associated with each category. Then I am going to have another type that is known as cumulative frequency distribution. So in the cumulative frequency distribution, sum of the first frequency and all frequency. Okay, so dear student, I am going to have the relative frequency. Now I am going to find the sum. Okay, when I add the frequency, I am going to get the cumulative frequency, that is known as sum of the first frequency. So these are the 4 different types of frequency distribution. Now dear student, I am going to have frequency distribution table. See here, a frequency distribution table is nothing but the chart. Okay, it's nothing but the chart that shows the frequency of each item in a data set. See here, if I consider red, green, blue, black and yellow, this is nothing but the data set. Now I want to identify the frequency of these data set. So what I will do, I'm going to draw the table and I have the category and I have the tally marks. Okay, and these are nothing but the frequency. And if I consider this tally mark, I have total 5 lines. So what is the frequency? It is 5. If I consider second row, that is green, I have 6 lines. So 6 frequency. Here it is 2, frequency is 2. Here it is 1, frequency is 1. Here it is 3, so frequency is nothing but 3. Okay, now the type of frequency distribution table. In the sense, I'm going to construct the table for different type of frequency distribution. In that first one, I have grouped frequency distribution. So here I'm going to have the class interval. In the sense, I'm going to have the group of data. So to arrange a large number of observation or data, we use grouped frequency distribution table. So dear student, think that I have the data range that is 1 to 100. So it is long data. Okay. Now I'm going to divide this one into 1 to 10, 10 to 20, 20 to 30, so on 90 to 100. Okay, so to represent the data in the form of group, I'm going to have grouped frequency distribution. Now dear student, see here, this is the example problem I have. Marks obtained by 20 students in the test are as follows. So 5 marks, 10, 20, 15, 5, 20, 20, 15, 15, 15, 10, 10, 10, 20, 15, 5, 18, 18, 18, 18. Okay, now what I will do, if I consider this one, this is nothing but the class interval, or it's nothing but the grouped frequency distribution. So I'm going to categorize the data, that is 0 to 5 marks, then 6 to 10 marks, 11 to 15 marks, and 16 to 20 marks. And if I consider the range 0 to 5, I have 3 numbers, and 16 to 10, 4 members. 15 to, that is 11 to 15, it is 5 members. 16 to 20, it is 8 members. And when I add all this frequency, I'm going to get the total number of students, that is 20. Now, this is the another table for ungrouped frequency distribution. See here, all the values are different in the sense this data are not comes under group data. So I don't have any class interval and I don't have any range. Okay, so here I have the marks like 5, 10, 15, 18 and 20. Okay, so 5 marks scored by 3 members, 10 marks 4 members, 15 marks 5 members, 18 marks 4 members, as well as 20 marks 4 members. So dear student, for this example also I'm going to consider same data set. Okay, but first I'm going to consider group data. Now I'm going to consider ungrouped data. So if I consider ungrouped data, I don't have any range. Okay, directly I'm going to take the data. For that, I'm going to find out the frequency. Now, I'm going to have my first example that there are 20 students in a class. So, how many students? 20 students. The teacher, Miss Jolie, asked the student to tell their favorite subject. The results are as follows: maths, English, science, maths, science, English, arts, mathematics, science, art, science, mathematics, arts, mathematics, English, and mathematics. Okay, these are the data. Okay, I have group of data. Now, I want to represent this data in the form of frequency distribution. Okay, so here I have how many students? 20 students, and I'm going to make three different columns. In my first column, I'll write subject. In next column, tally marks as well as number of student. And if I consider 4 members, their favorite subject is arts. And 7 members likes mathematics, 5 members likes science, and 4 members likes English. So total it is 20 members. Now dear student, let me to consider another example here. Okay, 100 schools decided to plant 100 trees. So 100 different schools decided to plant 100 trees. Okay, now represents the given data in the form of frequency distribution and find the number of schools that are able to plant 50% of the plant or more. Okay, now I have the data set. Okay, this is nothing but the example for data set. Okay, solution. To include all the observation in group, we will create various groups of equal interval. Okay, so I'm going to create the interval in the sense 0 to 10, 10 to 20 and so on. These intervals are called class interval. So this is known as class interval. In the frequency distribution, the number of plants survived is showing the class intervals and tally marks are showing frequency and the number of schools in the frequency in numbers. So there are 3 columns. Okay, one is nothing but the class interval and another one is nothing but the tally marks, that is nothing but the frequency, and another one is nothing but the number of schools, that is nothing but the frequency in numbers. Now let me to construct the table here, and if I consider the number of plants, okay, the class interval 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89 and 90 to 99. So dear student, if I consider the frequency, that's nothing but the tally marks. Okay, so 3 school, the range is 20 to 29. So 3. And if I consider 30 to 39 class interval, then 14 schools. And if I consider 40 to 49, 12 schools. Okay, 50 to 59, it is 8 school, 60 to 69, 18, 70 to 79, 10 school, and 80 to 89, it is 23, and 90 to 99, it is 12. And when I add all these numbers, I must get 100. Okay, fine. Now, according to the class interval starting from 50 to 59 to 90 to 99. So I want to consider the class interval 50 to 59 to 90 to 99. Okay, the frequency of schools are able to retain 50% or more than 50%. In the sense, when I add from 8 to 12, I must get the frequency distribution more than 50 or 50%. So when I add, I'm going to get the number that is 71 schools. Therefore, 71 schools are able to retain 50% or more plants in their garden. Anyway, dear student, in my today's session, I started with what is frequency distribution. Along with that, I have discussed the different types of frequency distribution along with some example. Anyway, dear student, in my next session, I'm going to deal with mean of grouped data. Until that, keep watching and keep learning. Thank you.